The ability to quickly adapt to changing situations is a critical feature in general intelligence. This type of fast learning relies on effective ways to collect new data and strong inductive biases during learning. A promising recent approach in model-based reinforcement learning combines episodic control with planning by constructing a topological world model from observations. Our key insight is that this graph offers a critical structure in organizing knowledge during fast adaptation. The problem, however, is that these methods produce policies that are local by nature, so when acting without high-level plans, these local policies often fail to reach long-horizon goals. Our work aims to answer how can we learn long-horizon reactive policies in the face of environment non-stationarity. To answer this question, we present learning from graphical replay. It's a framework that decomposes the problem of learning challenging long-horizon visual motor control policies into two sub-problems: learning and improving this model, and supervised learning a reactive policy from model-based unroll. Our contribution includes two supervised schemes for learning the policy. The first one is called Universal Value Prediction Network. It's inspired by Q-learning. And the second method is called goal-relabel expert distillation, and is inspired by offline policy gradient methods. We also include a specific way to improve the graph with causal structure learning and show empirically that this is key to the success of the policy. We present three main results. First, we demonstrate robust episodic adaptation by reenacting the Kerplunk experiment from 1930s. In this experiment, the agent starts with the ability to traverse this maze. We then insert the wall, which forces the agent to update the graph by removing these edges that are now invalid. This episodic approach allows the agent to learn instantaneously without gradient update, which translates into this monotonic improvement over 4 consecutive episodes. Next, we show that learning from graphical replay enables sample-efficient adaptation. In this experiment, we evaluate the reactive policy as opposed to the semi-parametric controller in the previous slide. We show that despite the changes to the graph are limited to areas around the inserted wall, the change in value estimate occurs over the entire domain, which results in global changes to the adaptive policy without additional samples where the dynamics is not affected. Finally, we answer why we want to distill the graph into a newer policy. We show quantitatively that the learned network policy is able to generalize, resulting in behavior that is less spurious in comparison to the semi-parametric control policy and the high-level plans. For additional results on difficult context-rich tasks such as peg insertion and object manipulation with a simulated robot, please refer to our website.